Hey everyone, I've got news! As you can see from behind me, it's TinyPICO related. I have finally launched this little guy as a pre-launch on Crowd Supply. Yes! I know it's been a super long journey, but it's finally happened. So, what's a pre-launch page? Well, it's kind of like a coming soon page, so it's public, so people can see that TinyPICO is coming, and allows people to register for interest and be notified when the campaign actually launches. So it gives Crowd Supply a way of seeing if people are interested in the product, and it allows me to see if they're interested as well, which I hope they will be. I don't know when the actual campaign itself will launch. I've got a lot of marketing to do now that the pre-launch page is up, and I have more review samples to send out. I need time for actual reviewers to get them and have a look at them and potentially do videos or use them in projects. And I guess over the next little while I'm going to be spending a lot less time doing electronics and doing making, and more time working on marketing and administration and everything else for the campaign. It takes a lot of work to actually run a crowdfunding campaign. But I'm up for the challenge. So let's have a look at the current state of the TinyPICO. And here it is. This is the current version of the board. There is one more small revision that's happening for the production boards. I'll go through that in a moment. But this is a fully working board with RAM on the back. And the main key changes since the last time you saw the board are I've moved to a surface mount only USB connector again instead of the peg hole connectors. What I've done though is made a completely custom footprint for it, and I've now got mechanical strength at the back of the USB as well. I've got better mechanical strength at the sides. So that means that I no longer get the peg leg sticking through the bottom of the JST connector, which looked a little bit ugly, and it makes it easier to solder the JST connectors on. Another noticeable difference is that the back of the board next to the RAM, there's now a power solder jumper that you can cut power to the PS RAM. So for those people that want to use ultra low power for really long battery life for their projects, they don't necessarily need the extra RAM, they can cut power to that and save about 80 to 90 microamps, which is a significant amount if you want, a really long battery life. And you don't need the RAM, then cutting the power is an option now, just a convenience. Other changes to this revision are I'm now using a PNP transistor over here as a high side switch instead of using an NPN as a low side switch, which wasn't working reliably. So you can now cut the power to the APA when you want to, especially when you want to go into deep sleep, and save that 1 milliamp of quiescent current that the APA takes, which is crazy amount of current. I've also worked out how to reduce the component count and take off 2 of these resistors. There were 2 resistors over here that were connected to my charge detection system to detect whether the battery is in charge mode or not. And I've worked out another way of doing that where I can actually remove them both. In this particular board there's 1 resistor missing, and I'm just using 1 0 ohm resistor to simulate the same result. But the production boards will have 2 resistors less, which is pretty cool. Less components is better. And the other thing I've done on this board is actually just move some components around to make it easier to hand assemble. You might notice that the resistor that was over here, the pull up for the reset line, is now over here, just to make some more space. So I've just rejigged some things to make it easier to hand assemble the boards. But there it is. That is what I'm calling my production 1 board. And this could absolutely go into production as it is right now, and I'd have no problems releasing these boards. But one more revision that'll happen on the actual production boards themselves will just be a reduction of a couple of parts. Saves cost, saves time. So it's really hard to tell how big this is. I mean, I know you can see my fingers here. I've mentioned that the board is, smaller than my thumb, and it kind of is because I can cover it with my thumb. These grids over here on my mat are 1 centimeter grids, so you can see kind of how big it is. But to really get a good understanding of how big the board is, here it is next to a Room 32 module. As you can see, it's as wide as the module. It's a little bit longer, but if you consider that the TinyPICO has onboard USB, it's got an APA 102, it's got extra RAM, it's got LiPo charge circuitry, it's got broken out headers, and a 3D antenna, which is a lot better than the PCB antenna. That's a lot of stuff packed in to something that's such a small size. To give you another reference point, here it is next to a D1 Mini, which is the go-to board for a lot of people for small IoT projects. With the TinyPICO you get all the benefits of an ESP32, all the extra I/O, ADCs, DACs, plus you've got extra RAM and battery and everything else, and all on something that fits inside the pin space of a Wemos D1 Mini. Yes, it is really small, and it's very cool. So that is my exciting news. How cool! I'll link to the Crowd Supply pre-launch page below in the description. Please check out the page and support me by registering your interest on the page. It'll go a long way to helping me as I prepare for the campaign. I look forward to keeping you updated on how I'm going on that journey. I hope to get the actual campaign up as soon as I can. I don't know when, but sooner than later. And I can't wait for it to go live and hopefully get TinyPICOs out into people's hands. Very exciting. Anyway, that's it. Thank you very much. Thanks for watching. Please spread the word about the pre-launch page if you can. I'd appreciate the extra noise out there in social media and stuff. And until next time, catch you on my live stream.